Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 4, which is about triangles and congruence. And this lesson is called Prove Triangles Congruent by Angle, Side, Angle, and Angle, Angle, Side. Our central question is, how do we use angle, side, angle, and angle, angle, side to prove triangles are congruent? We have a warm-up here. It says decide if you would prove these triangles congruent by side, 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 angle, side, or hypotenuse, leg. Why don't you guys see if you can figure this out? All right, for number one, I don't see any angles marked here, and I do see that I have a reflexive shared side here. So we have three sides that are congruent, so this one should be side, side, side. Okay. The second one, I see we have a side and an angle that are congruent, and I also see that we have another shared side right here. So if you go around the triangle, you can see it goes side, angle, side. Okay, so it's going to be side, angle, side for this one. Okay, you always want to go around the triangle and see, like, if the angle were over here, that would be can't write that. That would be side, side, angle, which is not a thing, right? So we can't. You have to be careful where the angle is. For side, angle, side, the angle has to be between the two other congruent sides. Okay. All right, let's talk about some new congruence postulates here. We have angle, side, angle. So you can see here, if we zoom in a little bit, it goes angle, side, angle. Okay, the side is between the two congruent angles. Angle, side, angle. All right. So what goes in the blanks here? Angle A is congruent to what angle? Angle D. AC is congruent to what? DF. Angle C is congruent to what? Angle F. And triangle ABC is congruent to triangle DEF. All right. And in a similar vein, we have angle, angle, side. So you can see here, if we go around the triangle, we have angle, angle, side. So this time the side is outside the two angles, okay? So we have angle, angle, side. The side is outside the two angles. And this one over here is between them, okay? So we have angle A is congruent to what? Angle D. Angle C is congruent to what? Angle F. BC is congruent to EF. And triangle ABC is congruent to triangle DEF. All right, sounds good. Okay, why don't you, it says, can the triangles be proven congruent with the information in the diagram? If so, state the postulate or theorem you would use. Why don't you guys pause the video and see if you can give this a try. Okay, well, let's go. So we basically have angle, side, angle, or angle, angle, side here, okay? So for these kind of problems, you want to see if you have any vertical or vertical angles or reflexive shared sides. So in this first one over here, I see that we have vertical angles here, right? But is there such a postulate as angle, angle, angle? Is that a thing? It is not. You could actually have two triangles with all the same angles that are different sizes. For example, you could have a triangle like this and a triangle like this that have the same angles, but they're also different sizes. So this is going to be no, okay? So we're going to say no, angle, 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 not a congruence postulate. Okay? How about the middle one here? Okay, looks like we have two angles congruent. Are there any vertical angles or shared sides? There is a shared side in the middle here. So if we go around the triangle, we have angle, angle, side, okay? Angle, angle, side. So this is going to be yes. And we have angle, angle, side. You also want to check with the other triangle that it's going the same direction. We have angle, angle, and then the side is outside the two angles. So that is correct. All right, how about the last one here? Looks like we have an angle on a side. So it's going to be either angle, angle, side, or angle, side, angle. Do we have any reflexive or shared sides? No. Do we have any vertical angles? We do. We have some vertical angles here. So if we go around the triangle, you can see we have angle, side, angle, right? The side is between the two angles. This one's going to be yes. And we have angle, side, angle. Okay? That's why they're congruent. Okay, these checkpoints, see if you can do these checkpoints. Now we've gone through a few of them, see how you do. All right, so can they be proven congruent with the information given in the diagram? So let's talk about this here. So we have two triangles. I'm going to highlight these two triangles here. We have this blue one right here, We got that one, and then I'll use red for the other one. We have this one right here. Okay, these are two triangles we're talking about. So I'll pause the video now that I've outlined them, see if you can tell if these are congruent or not. Okay, so yeah, for these two triangles here, for the red triangle, we have these are both 60 right here, right? We have a right angle, and then do you see any shared side or vertical angles here? I do. Down at the bottom here, there's actually a shared bottom side. So this one's going to be yes. Okay, this side down here is a shared bottom side of those two triangles. It's kind of a new, different orientation of those, but that is correct. It's going to be yes. It's going to be angle, angle, side. Okay, because it goes around the triangle, angle, angle, side, and angle, angle, side. Okay, how about the other one here? Looks like we have congruent angles. We got an angle, we got 90 degrees, and we got these angles right here. Do we have any reflexive or shared sides? We do. We have a shared side here. So if we go around the triangle, we have angle, side, angle. So it's going to be yes. And we have angle, side, angle. Okay? The side is between the two congruent angles, so it's angle, side, angle. All right, sounds good. We have a proof here. Let's see how we do with this. It says prove triangle ABC is congruent to triangle DBC, given that angle ABC is congruent to angle DBC and angle ACB is congruent to angle DCB. We're going to prove this here, okay? So we always we're doing our two-column proof, which is statement and reason. And we are going to, what do we start with? Easy points on the proof are given. So angle ABC is congruent to angle DBC, and angle ACB is congruent to angle DCB, and that is given. Givens. All right, step 2. Okay, so after that, we usually do definitions. Are there any definitions here? No. After that, we do reflexive or vertical angles. Are there any reflexive or vertical angles here? There are. Do we have any shared sides or vertical angles? We have a shared side right in the middle here. So I'm going to say that side BC in one direction is going to go the opposite direction, is congruent to CB. And the reason for that is reflexive property, shared side. All right, do we have enough information to prove the triangles are congruent? Well, let's see what we have here. We have, if we go around the triangle, we have angle, side, angle. Looks like we do. That's a postulate that we know. So if we could say for step 3, triangle ABC is congruent to triangle DBC. And the reason for that is angle, side, angle. The congruent sides between the two congruent angles. And there's our proof. All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.